what are we trying to do? We're trying to approximate the area under that curve using rectangles. First, let's do a left-hand endpoint with 6 intervals. What's the width? How many? Looks like I'm going from 0 to 12. So if I'm looking for my delta x, that's my change in x, my b minus my a divided by n. So here we're going to have that this is 12 minus 0 over 6. So our width is 2. Nice. Alright, so we can go ahead and we can mark that out. Here's 2, bam, there. And here's 2, bam, there. Here's 2, bam, there. 2, 2, and 2. Oh, it partitioned it into 6 intervals. Good times? So if we're doing left-hand endpoints, which one's your left? It's the one on the left. So we're looking at, this rectangle here. And this rectangle, no, don't do that. This rectangle here. And this rectangle here. And this rectangle here. And this rectangle here, where we're using the left endpoint. Oh, it worked out nice there at the bottom of the curve. And we're going to add up those areas. And that's what's happening at left 6 over here. So, what's my height of my first rectangle?
9.
Looks like 9. Fine. So it's 9 times 2. It's length times width plus, wait for it, what's the width of my, or what's the height of my second rectangle? 8.8. Okay, sure. 8.8. Does that sound right? Okay. So that's 8.8 times the width, 2, plus, looks like my next one's like 8.2. Let's say 8.2. Can somebody be multiplying this out while we're writing it down? Because that would be great. That way we don't have to wait for your computation. So then that was 8.2. Looks like our next one is in the 7s. So we're going to add that to, what is that? Is that 7.2? We're eyeballing it. We're making a nice guess. And then, yes, plus, I'm going to go down here, plus, lack of forethought, plus, our next one looks like 6. 6 times 2. And then our next one looks like, is that a little less than 4? 3.9?
Actually, it's about exactly 4, because it crosses 10.
Oh, yeah.
10 maybe above 4.
Let's use 4 then. Nice numbers. Bam. This is nothing to sneeze at. And then what? What did you get when you multiplied and added all those up? How many? 86.4 going once?
Yeah. That's about right.
Going twice? 3 times. Sold. 86.4. Box and flour. So, if we were going to do right-hand endpoints, if we were looking at R6, we'd use right-hand endpoints. So, just go ahead and get rid of this. We'd be using right-hand endpoints. So, we go to our first deuce, and we're looking at this, and then we're looking at this, and then we're looking at this, Oh, that's fat. And this. And then this. And then this. And because our graph is decreasing, oh, you can't see that very well, can you? Because our graph is decreasing, this is going to be an underestimate, whereas our left-hand endpoints, was that an overestimate? And then our actual area is going to be between those. I'm not actually going to computate this or calculate this.